Good evening, everyone. Good evening, everyone. I'm not hearing anything. Hope I'm audible to everyone.
Yes, good evening all. Hope I'm audible. Okay, thank you. We'll start now. Good evening once again. Today we'll be going through P&IDs, piping and instrumentation diagrams. This is a kind of these documents are kind of Bible for any process plant. Okay, we'll go ahead. So, what is a P&ID? It is piping and instrumentation diagram. We all know that entire process plant, any unit, is made up of piping and instrumentation. Instrumentation for control and piping are connecting different equipments of the process. So this document gives a detailed view of where and how the pipes are connected, what are the instruments in that pipeline, what are the instruments in that equipment. So all these details are given in P&ID. So it's like a blueprint. So it's one of the most important engineering document in any process plant. So P&ID actually it's a graphical representation. Of course, you have come across block flow diagrams and process flow diagrams. So this has much more details. It almost replicates the plant on a drawing sheet. So it gives the flow direction. Each and every equipment and instrument are tagged, are named as we all are. And it shows the purpose of that instrument, whether it's measuring flow, pressure, temperature, analyzer, and how the control scheme is. And for equipment, we have all the required details. Pump, it has this head developed, what's the power, flow delivered, everything. So columns and vessels will have dimensions. So pipelines will have only tag numbers and size. We don't have any measurements there, like length, elevation. These are not available in P&ID. Actually, P&IDs are not scaled. So, as we already said, P&IDs form the basis for engineering and construction of any process plant. So, P&ID is the most important document from which other disciplines take inputs for further engineering. For example, these are the main documents which are related to P&IDs, for which P&IDs form the basis. Process operation, for that we'll have procedures. To make the procedure, we should know the flow scheme in detail. So where the walls are, where the equipment is located, how we are going to take the equipment in line, how we are going to shut down the equipment. So everything will be clearly shown in P&ID. Procedures will not be shown in the P&ID, but we need to develop the procedures based on the P&ID. We need to close this wall, we need to open this wall, all this. Cause and effect diagram. Cause and effect diagram is nothing but emergency shutdown systems. So it shows in case of any emergencies, any uneven conditions in the plant will take its own shutdown. So that forms cause and effect. What if high pressure is there, what will be the action taken automatically? So this diagram will also be developed from P&IDs. Then for mechanical, so the mechanical team will develop data sheets, isometrics. Isometrics are nothing but extended version of P&IDs where the pipeline length and elevation are scaled or the measurements are given. So this is isometrics. So isometrics are made from P&IDs. So how many manual walls are there? What will be the insulation thickness to be provided? So all these details is derived from P&ID for mechanical. Instrumentation again. So instrument will develop their data sheets. So all these data sheets are related with process because we'll be issuing process conditions. So what is the temperature, pressure at which my instrument should operate, at which the wall should operate. So for only any equipments or instruments are designed for certain conditions, process conditions basically. These are given in P&IDs, and of course a detailed HMB will be available, which has much more details. So what are the control walls? What are the shutdown walls? So shutdown valves are linked with cause and effect diagram. Okay. And control scheme. So how the flow is controlled, how the pressure is controlled. So everything will be available in P&ID. And electrical, of course, it has minimal interaction in P&ID, but these are very significant. Heat tracing requirements. Suppose if the plant is in a colder region, so then we need to maintain temperature, because atmospheric temperature will be much lower than the process temperature, and that should not affect the process. So maybe electrical heat tracing would be required. So from where, in which lines do we give, it does the process needs electrical heat tracing, that is given in P&ID. And interlocks, there are times where we need to trip the equipments, whether it's a pump or compressor in case of an emergency. So that how it is interlock, how it is connected to the process, everything can be arrived from this P&ID. So thus P&ID forms the basic document which every process engineer should know, whether he works in design, technology, operations, safety, whatever it may be. P&IDs is a must. It should be a base document for studying the plant. And of course, whatever is in P&ID should be in the field. And if there is any mismatch, that is to be corrected as soon as possible, because whatever is in the unit, it should be reflected in the P&ID. This is what a typical P&ID looks like. This is a separator. You can see all these numbers inside a circle. Basically, they indicate instruments. PG, TG, TE. You have PSVs here for protecting the vessel. You have all the inlet lines shown. Whatever is coming to the vessel and what is the source, everything is clearly indicated in the P&IDs. So you may represent a process in a single PFD, but PFD is a much more detailed document where the same process will be kept in different pages, or it will require many documents to depict a plant. Okay. You can see the drain lines, PSVs, all the inlets and outlets. So you'll see the instruments there, level gauges, the level measurements given here, how this level measurement is connected to the level control. You see logic here, instruments, basically they are given in dotted lines, control schemes. So this level basically is controlled by this equipment. So that is given. So this is how a typical P&ID looks. So it will contain whatever the plant should have in the field, everything will be available in the P&ID. P&ID is like Bible for all the process engineers, for the process plant. So now we have got a overview of P&ID. Now we'll get into further details. As you see here, this is block flow diagram. PFD we saw yesterday. It has much more details than process flow diagram. And if you see that this process is represented in P&ID, which has much more details than PFD. Here only one inlet outlet is shown. Here you have these inlet lines, you have the shutdown walls, you have the drain lines shown. So everything will be shown in the P&ID. So this is how the detail increases across the documents. So now we know how what's a P&ID. So now to prepare P&ID, so what all the things we'll be requiring. We should know this. This is important. We need the process flow diagram. Then we need a basis for making the P&ID. So design conditions, why they are required? Because in P&ID, we will be sizing the lines and equipments. So only based on design conditions, we'll be able to size the lines and equipments. Then control philosophy. How we are going to control the process. Isolation philosophy. Control philosophy, isolation philosophy, we'll be seeing in detail tomorrow. So vent and drain philosophy, tagging philosophy. Tagging is nothing but how we are going to name the equipment. That is much more important. Then material selection diagram, what our metallurgy friends will be giving us. So for a certain process, what metal is suitable. So we'll have the conditions, they will have the metallurgy. So both will be combined, both the data will be taken and it will be given as an input for P&ID. Piping material specification. So what rating we should use, what kind of pipe standard company has fixed. So everything will be given in piping material specifications. So with all these inputs, because this PMS and material selection diagram, in P&ID, the line number will be having what metallurgy the line is. So all these are important. So with these details, we will be preparing the P&ID. So this is how P&ID is prepared. These are the input documents for the P&IDs. Now, first, after get now we know what are required for to make a P&IDs. Now, what actually a P&ID conveys, we have already discussed. We'll just go through. It is nothing but engineering details of the plant. They have each and every line, wall, cooling lines, drain lines, vent lines, isolation walls, equipment isolation wall, number of equipments. So everything will be given in P&IDs. For example, for equipments, the number of nozzles will be available. Where is the vent? Where is the drain? How blind flanges, connecting lines, everything will be given. Complete details of interconnecting piping, including line sizes, different type of walls, materials, everything. Sorry. All process and safety instruments coming in the plant, including the tag numbers. And for PSVs, set points are also provided. We'll be seeing it in detail tomorrow. Basic process control schemes. So there are different types of control schemes, controllers. Everything will be given in detail in P&ID. All relevant basic information that is required for the construction of the plant. In addition to this, or this is very important, this signifies the importance of the P&ID. So P&ID legend. Legend is nothing but a guide. It has the symbols which is to be used for the entire set of P&ID of the process plant. How to number the lines and how to tag the instruments. So general notes and how a standard hookup, typical piping arrangements, sample points, drain lines, how it should look for that project, for that plant. Everything will be given in legends. Now, so see, this standard may differ from company to company. Okay. People will have their own standard, but these are typical legends. With this, you can understand the process, and this can be implemented everywhere. So this is how a typical line number looks like. First is line size, then is fluid service, LPS. So this will also be available in the legend. Here it can be assumed as low pressure steam. So this is a unit number, and this is a line number. That's a typical number which may be 1, 2, 3, 4, 5, anything. Then we'll have the piping class specification, which class it is, carbon steel, stainless steel, everything. Based on the piping material specification document, we'll use this code. Some may have A, some may have B, some may have C. So it will depends upon the company. M insulation type. So M may be minimum thickness insulation, mineral wool, anything. It will be clearly given in the legends. This is how a typical line number looks like. So these are different symbols. PC pressure controller, I is pressure indicator. This is local instrument. This is board mounted, means it is available in DCS. PSV pressure safety valve. Level alarm, high level alarm. And one more important thing is the type of valves. You see gate valve is shown here like this. Globe valve is shown like this with a dot in the center. Check valve. Check valves are non-return valves. Will have flow direction in one side only. Flow from opposite side is will not happen. Control valve, plug valve, ball valve, butterfly valves. Audible now? Am I audible?
हा
Am I
लागलं
audible?
तर विचारतो म्हणलं म्हणजे कुठं पाठवणार आणि तिथून काही रिप्लाय आला तर काय सांगणार मग इथंच भेटला इथंच बोल
And this is how pneumatic signal is represented, electronic signal, hydraulic signal. So these are various used for various control systems. So fiber optic signal, electromagnetic signals, so various data communication signals, all are represented in the legends. So legend gives us details required for making the drawing especially. So what symbols we should use, how the lines should be, everything will be given in legends. Now we'll go through how equipments are represented. Centrifugal compressor, turbine driven centrifugal compressor, axial compressor. So these are how motors are represented. This is a motor driven centrifugal compressor. So agitator or mixer, reciprocating compressor, liquid ring vacuum compressor, compressor, rotary compressor. So each and every compressor will have their own symbols. So based only after seeing the symbols, we'll be able to conclude. Steam turbine. So how a furnace looks, how a boiler looks. Hope I'm audible now.
Yes, sir, you're audible.
Sorry.
Shiva, sir.
Can you see my screen? Is the screen visible?
Yes, sir.
Yeah, okay. We'll proceed. We'll proceed. No issue. So we have seen the legends, the line numbering system, and now we'll see how different equipments are shown, because legends we'll be taking the symbols and we'll be using it for making the P&IDs. So these are typical legends, need not be in this exact shape. It may differ from company to company. So centrifugal compressors are represented like this. Turbine driven, this is motor driven compressor. And you see motor symbols, you see turbine symbols here. Here you have this positive displacement compressors, reciprocating, rotary, everything. So you have positive displacement blower, furnaces, boiler. This is how they are represented. These are typical symbols. So before studying any P&IDs, it is important to understand the legends so that you can easily connect with the process represented in the P&ID. You should know which equipment is used, whether it's reciprocating or centrifugal compressors. So that symbols are available in the legends. So it is important to go through legends before studying any process. So now, uh, normally P&D drawings are numbered in the order of the process. So right from the start of the process to the end of the process. Following are the main parts. So drawing numbers and details of the project. And you'll have the graphical representation of the process in the form of vessels, pipelines, equipments, everything. And it also has the details of all process and utility piping. details of instruments and control schemes. This we already saw. So all this will be available in the P&IDs. All the safety shutdown requirements. So this is the process safety part. Process and parameters like operating pressure, temperature, mechanical design conditions, what is the maximum design pressure, what is the maximum design temperature for that equipment, that is also mentioned in the P&ID. Process notes, any special instructions to be given for further designing team or the operating and maintenance team, that is also given in P&IDs. We'll see that in later part. So vendor package details. Few equipments are bought as a package. Vendor they themselves design and they'll give it to us. So that demarcation is also done in P&IDs, whether from where the vendor package starts. Interface details or any engineering information which requires further engineering or justification, those are kept as hold. This is to be clearly indicated in the P&IDs. So wherever you are not certain, I mean, I'm talking about the engineering side, engineering part. Whenever there is a dispute or there is a doubt, so hold is clearly mentioned, because wherever hold is there, that informations are not final. Now, in general, equipment symbol shape shall be as per P&ID legends. So elevation or minimum difference, that is, this should be minimum 10 meter from this equipment. So like that details we'll mention. We'll not mention the entire dimension of the line or the elevation. Equipment and installed spare shall be shown in realistic proportions. In PFD, if there are two equipments in PFD, it is shown as only one equipment. But in P&IDs, both the equipments will be shown because both will have their own inlet and outlet lines, of course, drain and vent lines. So in PFD, if there is A cross B, it means one equipment. In P&ID, it will be shown as two equipments with different connecting lines. No scaling is done in P&IDs other than the special elevation or minimum difference that has to be mentioned. That will be indicated for equipments or some lines, but no actual scaling is done in P&IDs. Skirts for column reactor vessel shall be shown, over which it is mounted. Vessels separators. So details of internals like impingement baffles, main internals be shown. So what are the main important internals in the vessels and separators? Nozzles will be clearly shown: inlet, outlet, drain, vent nozzles, thermowells, sample connections, from where the sample will be drawn for analyzing, vents, drain walls, flanges, spectacle blinds, relief walls, including the size and set pressure, that we'll see later. Notes regarding internal coatings. If there are any special paint or coatings to be given, that will be given in notes. All the level instruments will be shown. Here you see, this is how sorry, a typical vessel looks like. You have the inlet, you have gas outlet here, from there it is coming here. Actually, three-phase separation happens: water, oil, gas. You have an inlet diverter, you have a mist extractor, is nothing but this will not allow oil particles or liquid particles to get carried in the gas stream. You have this level control. So this valve is controlled by this indication. Then this is the outlet line. You have a pressure differential controller, because that is the basis for hydrocyclone operation. So if you see equipment in detail, all this will be there. This inlet line may have different lines from different P&IDs, different equipments, but this is only the vessel we have shown here. So this may join another outlet line, this may join another outlet, and this may go to another equipment. But a typical vessel is shown like this, a three-phase separator, gravity separator. Because the inlet contains oil, gas, and water. Heat exchangers. Heat exchanger symbol will be shown as per TEMA. Heat exchanger, all the inlet and outlet nozzles will be marked. Heat duty, how much energy is exchanged, that is clearly shown in near the heat exchanger. The details are available in P&ID. Air coolers. So number of fans available, whether lowers are there. Lowers are nothing but manually opening and closing the top. Uh, it's like a valve actually. It will increase or decrease the airflow through that fin fan. Whether it is available or not, that will be indicated. If you see here, now we are not showing the entire P&ID. As we saw in the vessel, we are showing only the typical heat exchanger. You see the inlet line. This is the tube side inlet and tube side outlet is there. We have a bypass line. In case of equipment is to be isolated, we'll have a bypass here to that equipment. If you see, this is the shell side. You have this inlet, you have this outlet. You have a bypass line. We have isolation lines. We have isolation lines. It is shown in the P&ID. Here you have the vent lines. You have this pressure gauge. You have this relief wall. You have this symbol you see where a black and white circles are there. These are blind flanges. This is the blind flange and this is the blind itself. So now you see here the white is nothing but open, black is nothing but closed. If it is reversed, then this will be closed. This is not the normal path. If it is white is in the bottom, it means that it is open now. It is in line. Whenever it is taken out for maintenance, we'll put black in the bottom. Okay, that is we'll blind that equipment, we'll isolate that equipment, and we'll clean the heat exchanger. So this is how a heat exchanger is shown in a P&ID. You see this inlet lines, outlet line, bypass line, vent line, everything is shown. Air coolers. Typical air coolers. You see the fin fan here. This is the inlet and this is the outlet. Here you have the fan. Here you have the lowers. You have the vent lines. You have the same. In line with the heat exchanger, you can see the inlet and outlet walls where with blind shown. Blind condition shown, whether it is open or closed. So this is how air coolers are represented. Compressors. Compressor is a typical equipment. It's not a single equipment as we saw in PFDs. Compressors will be accompanied by a suction KOD. Compressors are designed for gas transportation, so no liquid should enter. KOD acts suction knockout drums. It will knock out the liquid. So gas first comes here and then goes to the compressor. So this will be shown clearly in P&ID. Then you have this anti-surge wall, capacity control systems, a suction and discharge instrument. Suction, you have a pressure PT, discharge, you have a PT, you have this control system, anti-surge wall. Everything will be shown, including the steel and the lube oil system. So it's a motor, it's a machine. It has bearings, it generates heat, friction. So you'll have a lube oil system for that. That lube oil system will also have its own P&ID. So Whatever is available in the plant will be available in the P&ID. So pump, you see here, it has the nominal capacity, what is the type of pump, what is the speed, what is the construction MOC, so what is the motor capacity, everything will be shown in pumps. So flare is nothing but the relief system. Whenever there is a over pressurization or any abnormal condition, the excess pressure, that excess fluid will be relieved to the flare header, where it is burnt in the tip of this flare and is sent to the atmosphere, because we cannot leave unburnt hydrocarbons or toxic gases inside that into the atmosphere. So this flare system is also clearly represented in the P&IDs. PSVs will have their set pressure, what is the capacity of the flare, how much tons it can handle, or how much volume it can handle. So what are the height, what's the height of that stack, what is the sensing element, what's the type of that flare, whether it is used for acid gas, whether it is used for hydrocarbons. So everything is clearly mentioned in the P&IDs. So flare system is of prime importance for process safety. So all these instruments and PSV should be in line for safe operation of the plant. Now we'll have a few more details. So winterizing protection. These are nothing but protecting the fluid from solidifying, because if the atmospheric temperature is very low, then that will affect the fluid inside the pipeline. So this is what happens. So in for that, so we'll be giving winterizing protection, we'll be providing hot insulation, we'll be providing electrical tracing, steam tracing, so which will be wound around the pipeline to keep it warm, to keep it hot. So these details are also clearly mentioned in the P&IDs.
Hello, sir.
Then, yes, please.
Can you please share once again, because PPT is not working, sir. Your voice is clear, but PPT stopped at compressor stage slide itself.
Just a minute, I'll check. Can you see now?
Yes, sir. Yes, sir.
Now we're able to see presentation is moving forward. Can you see pumps?
Yes, sir. Now it is showing flare
Okay.
systems.
Just a minute, I think there is a delay.
Yes, sir.
Now can you see the flare systems?
Yes, sir. Now.
Yes, thank you so much. So this is how a typical flare system P&ID look like. Okay, so you'll have from different equipments, it will go to the flare header. So this is the sub header. All these are connecting from different equipments. It goes to a KOD. From there, it goes to a stack. So this is how flare system is represented. So now we talked about winterization protection. So this is basically used when the atmospheric temperature is low enough to solidify the fluid which is being processed inside the pipeline. So we'll be making it warm by providing hot insulation, hot water jackets, steam tracing or electrical tracing. All these details are clearly mentioned in the P&IDs. Now, few more things. So whenever you have a line moving from one elevation to another, at times we'll be requiring to mention the slope. This is to avoid liquid accumulation in that line. So any liquid in the line should easily flow towards the lowest point, lowest equipment. So wherever we don't want any liquid stagnation, because liquid stagnation will have many effects. Few includes issues like corrosion. If there is a stagnant liquid, it may corrode the pipeline. So to avoid that, we'll slope the pipeline such a way that whenever liquid is formed or it comes in the line, it will be easily drained towards the next equipment. So should be clearly mentioned. Spacing of instruments. So if there is any bend immediately before a instrument, that should be avoided. That may affect the instrument performance. So that should be mentioned. You please leave 5D, 10D, 10 times diameter, 5 times diameter distance from the bends. That should be clearly mentioned. So location of blinds, where it is located, positive isolation requirements, vent and drain points. So everything should be clearly mentioned in the P&IDs. So now, first thing first. So we know what details P&ID has, but this part is more important. The entire, this is like the ID card of the P&ID. So in ID card, we'll have our name, numbers, agency contact numbers, everything, right? A company name, everything. It is same like that. First and foremost thing you should see in P&ID is this one. This red circle where you have for design approval everything. So this should be latest. Okay, whichever P&ID you use, that must be the latest P&ID, because designer may got some review. You would have went for review and you would have updated the P&ID. You should use the last and the latest P&ID available or approved P&ID available. So if you are going through a plant, if you are studying a plant, and if you use a preliminary P&ID, and that is going to confuse you, it will not be the same as the field, what's there in the field. So you should always use latest approved P&ID. So it will have title, description, project, who is the contractor, who is the engineering, which is the engineering company, who is the client, what is the drawing number, P&ID number, what's the project name, what is this revision control is very important. You should have the latest approved P&IDs for further engineering or even for studying the plant. Okay. So now we know symbols, how it is there, process connecting lines, everything we have read. There will be a separate section called notes section just above this revision control, or in the top right corner or in the bottom left corner. It depends upon the company, but you'll have a section named notes. So all notes must be clearly understood while studying the P&ID. Each will have a significance or input for further engineering or operation and maintenance. Example, field to blind connection, connection for used oil vessel drain. Pipe should be free of pockets and stagnant areas. You should mention a slope there. Complete respooling of lines may be required to tie in new lines. So all this gives some specific instruction for this is field to blind connection. This is mainly for maintenance. Connection for used oil vessel drain. This is for normal operating. And complete respooling. This is for So this is for engineering, and 5 should be free of pockets. This is for operations. So this is for further engineering, basically isometrics, elevation. They should take a note of this and provide slope accordingly. So all this information are required for a safe design and operation of the plant. So all this will be available in P&ID. That's why P&ID makes the Bible of any process plant. Isolation of the equipments.
Yes, sir.
How the bypass was. Yes, please.
Sorry to interrupt, sir. Still experiencing the same problem. PPT is not moving.
Is it moving now?
It is a flare system, sir.
Hello. Are able to see now? P&ID details is the slide. Is whether it's available. It's visible now.
I could see flare systems diagrams and those stuff, sir.
Able to see now?
No, sir. I could only see flare systems. Slide.
Okay. Just give me a few minutes. So sorry for the interruption. So now we saw the slope requirements. We saw that slope requirements. We'll just quickly go through what we discussed in last few minutes. Slope requirement, we told you, in case the process requirement requires any liquids not to be say stagnant in the pipeline, and the line to be designed with a slope towards the nearby vessel, that has to be clearly mentioned in P&IDs. So spacing of instruments, lines which will be used only for startup, so all these details should be clearly mentioned in the P&IDs. So before reading any P&ID, or this is the first part you should read in a P&ID. We should use only the latest revision. We should use only the final P&IDs for both engineering and operation. So this revision control is very important. So then we discussed about notes section. So what notes section gives is, it has many information for running the plant, for operation, maintenance, and also for further engineering, for future engineering. Everything will be given in notes. So each and every note will have their own significance, and it should be clearly understood by the respective team. So reading a P&ID, so we know the location of valves, bypass valve, purge connection points. Control scheme will be seeing in second session of P&ID. So we'll be seeing in detail how a typical control schemes, what are the different type of control schemes available. So now we are in the end of the session. So P&ID shall include the following. First and foremost is, whatever document we use, any engineering document, not only P&IDs, whether it is PFD, isometrics, data sheet, it must be the latest revision with the date and scope. Process flow with flow directions, equipment nameplate details, piping, metallurgy type, specifications, all the instrumentation's control scheme, all the equipments with their respective isolation and bypass walls, lock open and lock closed walls. This is because few walls are always to be kept open, few walls will be kept closed and will be used only during emergencies. So such type walls should also be clearly mentioned. Slope of the lines that we already saw, vendor packages, insulation and tracing details. All these details are mentioned in P&IDs. Now, so we'll see a typical P&ID. Whatever we learned, whether it's available in this P&ID. So you see the name, what is the capacity, so what's the name of that vessel, what is the design pressure is given here, what is the dimension, length and diameter is given here. So this is a pump, what is the design pressure, what is the capacity, 5 meter cube per hour. So for a pump, all these are mentioned. What is the head, the differential head it generates, so that is given. What is the power consumption at normal pressure, at set point, what is the motor rating. So everything is given in the P&ID. If you see this, you have this 25-inch. It's a, what line number shows the line size, what is the fluid processed, what is the fluid number, what is the metallurgy, everything is available in this line number. So then if you see the control scheme, you have a level control here, you have a heater control here to keep the line warm, to heat the process. You have a level control here, control it goes to this controller, and this output goes to this final equipment. So this pump is controlled by this level. So you have this drain lines, how all the instrument drain lines are connected. So everything is PSVs. You have the PSV set pressure 630 kPa. So you have this PSV inlet and outlet lines. So everything clearly mentioned in the P&IDs. How to isolate this equipment? You see here the blind flanges for all the inlet lines and the outlet lines. You have the blind flanges. So you have the blind flanges. So how you'll isolate this? Isolation valve is there. So like this, all these equipments are very clearly mentioned in the P&IDs. So this is what P&ID looks like, and this is what we should learn from the P&IDs. Okay. So now so P&IDs is the basic document of any process plant. So we know P&IDs, how it is made. We have legends which has the symbols which is how equipments are represented in the P&ID, how the P&ID is named, or how the line is named, how the instrument is named. Everything will be available in the legends. Then we should look after the revision. We should use only the latest revision of the document. Then we'll have all the lines with their names in the P&IDs, all the interconnecting lines, when to drain, everything, equipments with nozzles, dimensions, pumps and compressors with respective capacities, motor ratings, everything. So slopes, any special instructions which should be captured in the notes section. So all these are to be clearly understood for further designing or operating the process plant. So yes, and thank you. So this is what first part of P&ID is. In second part, we'll be going into much more detail. We'll be basically, as a process engineers, we need to understand the control schemes. So we'll be studying the different control schemes and special piping arrangements which are related to process safety. So these things we'll discuss in the second part. So now, thank you all. You can now, if you have any questions, you can post it in the chat. So we'll be happy to solve your queries.
Thank you, sir. Thanks for your wonderful and insightful session. We have few questions in the Slido link. I will address it now. So if anyone have any further queries, please raise your hand. It will also be addressed. Sir, the first question is, will P&ID show the capacity of the pump?
It will show the capacity of the pump.
Okay. The second, difference between PFD and P&ID. Will all the details in P&ID will be there in PFD or vice versa?
No, that will not be there. Maybe you ask pump capacity will be there in both PFD and P&ID. But how the pump suction and discharge lines are there, how the drain line is there, where the drain line is connected, all these details are available only in PFD, P&ID, sorry. So P&ID will have much more details than PFD.
Okay. The next question, what is interlock and line sizing?
Line sizing is, so we know the condition. So I have 10 meter cube of liquid to be transmitted from this place to that place, from this part of the plant to that part of the plant. Now I need to size a line accordingly. So we have that is a design procedure for sizing the line. That is line sizing. So line sizing nothing but making the optimum size required for the plant piping. And what was the second? Line sizing and interlocks. Interlocks are safeguards. If the level increases, there should be a inlet should come down, or inlet should be get closed. If in a vessel, if the level is increasing, keep on increasing, you cannot fill the vessel completely with water, because that's not designed for any hydraulic load, or that may damage the internals. Internals may get damaged. So in order to prevent any incident happening, interlocks are given. So interlocks will take safe shutdown. It will shut down the plant.
Okay. Next question. Difference between a transmitter and an indicator.
Indicator basically is a local indicator. It indicates in the field. Transmitter that transmits the signal to DCS, where plant operator from DCS will able to see that same value.
Okay. Difference between locally and board mounted instrument.
Yes, the same. It is almost the same. Local is field. Board means it is connected to DCS. Because in early days, DCS persons were called as board operators, because there they see all the equipment, all the instruments will be available in DCS.
Okay. One general question. As a fresher, how to get familiar with all the P&ID symbols? He means legend, I guess.
Okay. This very typical question, because even now I'm learning legends. So it differs from for different projects or different units. It's like over a period of time, you start remembering your father's mobile number, mother's mobile number. It's like that. Once you start go through the P&IDs, it will be automatically registered. You need not specially worry for this. Once you get into the plant, you'll come to know. Okay. Even I had this question as a fresher. Once you start working in a plant or in a design company, so you will it becomes a part of your job. So it will be you'll be remembering it automatically. You need not uh, stress yourself by thinking how to remember. Okay. So you'll automatically remember.
Okay. What is a liquid ring vacuum?
That's nothing but a type of pump which generates vacuum. It's like it pulls whatever is available in this equipment. It's a vacuum creating equipment. That's it.
Okay, sir. And next question. What is the anti-surge line?
Yes. So what happens whenever a compressor is operated? Compressor normally pumps from low pressure to high pressure. Gas is compressed and transported. So when there is a high resistance from the discharge side, there will be a sudden flow reversal. If that flow reversal happens, compressor will get damaged. So in order to prevent that flow reversal, a separate line is given from discharge to suction to maintain adequate suction pressure. Suddenly, if suction pressure drops, in discharge you have a very high pressure, suddenly there will be a reversal of flow through the compressor, which will damage the compressor. To avoid that, to maintain adequate flow and pressure in the suction line, anti-surge valves are given, and this is given typically for centrifugal machines. With that, you can safeguard the equipment.
Okay. Next question. What are pockets in a pipe?
Pockets are nothing but mixture of fluids. You have gas trap in that liquid line. So that will typically call packets, or a liquid trapped in a gas line. So that becomes a pocket there. In that flow, there is a pocket of liquid, there is a pocket of gas. That's it. It may create two-phase flow, and that may damage the pipeline
Okay.
if not designed for that.
What is ESD and startup override?
Okay. ESD is emergency shutdown system. So we'll be seeing in detail in the next part of this P&ID presentation. Startup override is that in during startup there will be not be enough flow or pressure. So we have to override that safety system just for few minutes. Once flow is established, because you're starting from zero flow, zero pressure, zero temperature. But ESD is given for 10 degree, 2 bar pressure, 10 meter cube. But initially everything is zero, right? In order to start the plant, you need to just bypass that. It's just telling that instrument this, we are just starting the plant, you don't take any action. So I'm muting you. Once flow is established, you take control. So we'll enable that. This is startup override. To start the plant, we need to bypass some instruments. That is only for few minutes. Once flow is established, we'll take that in line. That is startup override. We'll override the function of that instrument.
Okay. What is spooling and respooling?
Spooling is nothing but mechanical connections, actually, piping connections. Maybe you need to provide new spools there when you are going for additional tie-ins. So that is what.
Next question. What are isolation valves?
Isolation valves are the valves which isolate any equipment or instruments. So in this process line, if you close this valve, that equipment will be isolated, or that segment or that piping area will be isolated. So if you close that valve, that is the downstream of that is isolated. So that is called isolation valve.
Okay. Software to develop P&ID. One candidate wants to know about the softwares to develop P&ID.
Normally, it's done in AutoCAD, CAD drawing,
Okay.
and our mechanical friends help us in making the P&ID. So we'll give the scheme to them, we'll give the rough hand sketch, or we'll give a rough thing to them. Basically, these are developed in CAD, AutoCAD.
Okay. The vent pipe of your tank remains clogged during a pump out operation. This can cause dash. Is asking what it will cause. What is pump out?
Okay. Pump out is nothing but you're pumping out the fluid inside the tank. The vent is closed. If the vent is closed, what happens? It creates a vacuum because you're continuously pumping out. Okay. It's just like drinking a juice from the Tetra pack. So we all drink like fruity, Amul, Masti, that buttermilk. So once you keep on sucking that fluid, what happens at the last? That equipment, that Tetra pack buckles, right? So even if you don't apply any external force, it still buckles because you're sucking out entire fluids inside the Tetra pack. Same happens to the tank. If the vent is clogged, if vent is not open, so whatever is inside you're just sucking out, then that will damage the tank.
Okay. The next question, whether compressor and pump have the same legend?
No. No, not
Okay.
at all.
Okay, this is all the questions in Slido link. Participants, if you have further questions, please raise your hand. You can unmute and speak. Or else you can post in the chat box or Slido link. Oh, we don't have any other further questions today. One candidate is asking, piping clogged means.
Okay, clogged means choked. It is closed. It got closed by the impurities in the pipeline.
Okay. Hope we don't have any other further questions. Thank you, sir. Thanks for your valuable time and your patience for answering all of our questions.
Thank you. And still, if you have any doubt, please keep. We can discuss on Monday during the next session.
Okay, another question, sir. It is necessary to make P&ID in industry level.
Definitely, I told you, right? This is the Bible for any process unit, process plant. For safe operation and safe design, you need P&ID.
Okay. We can continue this P&ID session on Monday. For this session, assessment will be on Monday. Tomorrow, there will not be any assessment. For Monday's assessment, link will be shared Monday morning before 9 p.m. Mark your attendance in the link provided. Thank you all. Thank you, sir. Thanks for your time.
Thank you. Thank you. Thank you.